Question 7a. There are three aromatic compounds A, B, C. Compound A, it has the carboxylic acid or carboxyl group. B, it has phenol. C, it has carboxylic acid with one chlorine. First, you need to know which acid is a stronger acid. Okay, compare the relative acidity, and you must know whether it's the carboxylic acid is stronger or phenol is stronger. Please remember, carboxylic acid always stronger than phenol. So means it's always acidic than phenol. And after that, you need to compare this carboxylic acid and this carboxylic acid, which one is stronger. So the one that with chlorine is always a stronger acid. Okay, later I tell you what is what is the reason. So first, you need to put the comparison, the trend. Means the most acidic is the compound C, the carboxylic acid or carboxyl with the chlorine, followed by this compound A, and least acidic is the phenol, okay, compound B. So why the carboxylic acid is stronger acid? First, you need to know the carboxyl group in there is a carbonyl. Carbonyl is electron withdrawing. So means if you withdrawn electrons toward itself to the oxygen, and at the same time the OH bond will get weakened. Why? Because some of the electrons in the OH bond is moved to this electronegative atom. Means this bond, it will get weaker and easier to break. When it's easier to break, means it can form H plus easier. Means it's more acidic. And there is another reason why this one is a stronger acid than phenol. Because the delocalization of this lone pair. So this lone pair can delocalize within the COO, and the negative charge will move to the oxygens here. Means the oxygens here, these two, will share the negative charge, and therefore we say that it's more stable. More stable because the negative charge now is lesser, means it's shared by these two oxygen, and is less available to bond with the H plus here. So therefore, the H plus is more and is more acidic than the phenol. This is the reason why carboxylic acid is a stronger acid. And if you want to compare A and C, then you must include chlorine. So the carboxyl group is next to the carbon with one chlorine atom. So chlorine atom, we know that is electronegative atom, and also it can withdraw electron toward itself. And the carboxyl group itself also has one electron withdrawing group. Means now the OH bond is get further weakened. Means it's easier to break than A. It's form more H plus then. Because now it has two electronegative atom or electronegative groups. So it can withdraw electrons and further weaken this OH bond. Another one is this one. It can further stabilize the carboxylate. Why? Because when it's formed carboxylate, this one is electron withdrawing. Of course, this is the same. So the negative charge now is lesser on this anion. Means the anion has lesser negative charge, so it's less likely to bond with the H plus. H plus is more now, means it's more acidic. So we say that this one is more stable than A, more stable. means it's less reactive. Less reactive means it's less likely to bond with the H plus. H plus is more in the solution, is more acidic. If you understand what I'm telling you now, so means the explanation part you can answer. So this answer is actually from mark scheme, right? So I just take it, and if you understand what I told you just now, so you should be able to understand and answer this. And compound C is the one that has COOH, no chlorine. So compound C is the one that with one chlorine and the carbonyl groups, right? So it's the most acidic one. So because the compound C again, it has this and this group, so it's the most acidic one, and we say that this one is caused the greatest weakening of OH bond. Means the OH bond is weakest in this compound C, so it's easier to break. For compound A, it has the carboxylic acid, means it has the carbonyl group, so you can explain the electron withdrawing as well. In the compound A, it has one electron negative groups, okay, which is the carbonyl, and is able to stabilize the anion. So the stabilize means is withdrawn the electron, and it will let this carboxylate more stable, means it share the charge and is less likely to bond with H plus. And some of you might think, is it okay to discuss the lone pair on the oxygens in the phenol, delocalize in the ring, and is the acid? It's better not to really relate with the lone pair on the oxygens delocalized in the benzene ring. Eventually is less available and is an acid. Because in this comparison, we want to show is that the A and C is a stronger acid than B. If you mention the delocalization of the phenol, means the lone pair on oxygens to the benzene ring, so means you are telling this is also a strong acid. So therefore, what you need to do is you just try to discuss A and C, why they are more acidic, that's all. I hope you understand what I say. Part B. Methylbenzene, means the benzene with one methyl group, can be made from benzene by electrophilic substitution reaction. Part 1. Identify a compound that reacts with benzene to form methylbenzene. So in order to form methylbenzene from benzene, we must have methyl, isn't it? So we must use a halogenal alkane that can provide the methyl. So therefore, we use chloromethane. So the chloromethane has the methyl group, so it can use to form the methylbenzene later. So that's why the compound or the reagents that we need to use is chloromethane, means CH3Cl, together with the catalyst AlCl3 or aluminum chloride. So why we want to use this catalyst? Because we want to form the carbocations from the chloromethane. So the chloromethane will react with this catalyst. The catalyst will get a chloride from this chloromethane, and this one will form the carbocation, and the catalyst will form the AlCl4 negative. So therefore, this carbocation will further react with benzene to form the methylbenzene. Part 3. Describe the mechanism for the reactions between benzene and these carbocations. First, you need to draw one arrow from benzene ring. From benzene ring, do not point to benzene ring. must draw from benzene ring point to the carbon. Why? Because the carbon is the one with positive charge. It's a carbocation, right? So it's here. It's something like this. So you must draw one arrow from benzene ring point to the carbon. So this one mark. Draw the correct intermediate, means the ring with the curve and positive charge with CH and the methyl. So this intermediate one mark, and you need to draw another one, CH bond break, and this pair of electrons need to move back to the ring and restore the benzene ring. Because the intermediate is not stable, you need to form a more stable species. So by doing this is more stable and is formed the methyl benzene. Of course, do not forget you need to put plus H plus. So this is the one that being substituted. Part 4. Identify a suitable reagent to oxidize methyl benzene to benzoic acid. Methyl benzene is this to the benzoic acid. We need to do 2 steps actually. First, we need to use hot alkaline KMnO4. So this one is to convert the methyl benzene to this salt, to this anion, means the benzene with this carboxylate. And this salt or this anion need to be acidified, means we need to add acid solutions after that. So when we add the acid solutions to this anion, so this anion will get the hydrogens or the H plus to form the benzoic acid. So means the reagents that you need to put is hot alkaline KMnO4, then H2SO4 aqueous, means this is acid solution that need to convert this salt to the benzoic acid. So equation is very easy. The methyl benzene oxidize, means plus oxidizing agent to form benzoic acid plus H2O. So 1 oxygen used to form H2O, 2 oxygen used to form benzoic acid. So total you need to use 3 oxygen. So you just put 3 here. Part 5. Methyl benzene and benzoic acid are both nitrated with mixture of concentrated nitric acid and sulfuric acid to give mononitrated products. So just 1 nitrate group only. And the structural formula, they are this and this. Draw the structure for these 2 products. By now you should know which one is which one is the electron donating group and which one is electron withdrawing group. For the methyl benzene, because we know that the alkyl group is electron donating, so it's actually 2,4 directing, means when the nitronium form, and this nitronium will go to the 2nd and the 4th position, 1, 2, 3, 4. So it will direct to 2, 4 position because of this methyl group. Means the substitution will happen at the 2nd carbon and the 4th carbon. Or the 4th carbon, because it just form 1 product, mononitrated products. Another one you need to know is this one. The benzoic acid, the COOH here is electron withdrawing. It will direct the nitronium to 3 or 5. So means it will form these products. So you just draw these 2 products. Okay, that's the answer. Okay, part C. A reaction scheme is shown in this figure 7.2. So we have 4 reactions. It started with this nitrobenzene, of course with 1 methyl group. So it will form from this nitrobenzene, as you can see, is form phenylamine. So means this is a reductions of this nitrobenzene to form this phenylamine. After that, this phenylamine, it will react with some reagent to form this benzene diazonium chloride. So from phenylamine now form benzene diazonium chloride. So means reaction 2 is a diazotization, and the reagent that need to use is the nitrous acid, HNO2. Condition is below 10 degrees C, you just put 5 degrees C. So when we use this one and this one, then the phenylamine will form benzene diazonium chloride. Or in this one, you can put sodium nitrite plus HCl. You form this acid. Okay, so now reaction 3. The benzene diazonium chloride here, if you undergo reaction 3 and form this phenol, you can see that. So this one is the hydrolysis reaction. So means this benzene diazonium chloride will hydrolyze to form phenol. And after that, these two compounds will react and form the dye, molecule Y. Let's move on to part 2. Describe how this phenol can be produced from this benzene diazonium chloride. Means from this benzene diazonium chloride, from this. Okay, I told you just now, in the reaction 3, this one need to undergo hydrolysis. Means it needs water, and it needs hot condition, or you just put warm. As long the temperature is more than 10, it will hydrolyze. Right, so diazonium, these salt or ion, will hydrolyze at high temperature. Part 3. Part 3, this is quite challenging. It's the coupling reactions between the phenol and the benzene diazonium ion. So you need to draw the dye molecule Y when these two reacts. So I show you this one. If you can draw this structure is good. If you cannot, then you just draw this one. Okay, I will try to use the benzene ring. It's clearer so you can understand better. So we know that the benzene ring is actually, it has two groups, the methyl and this ion. And this phenol also, methyl and phenol. Actually, this molecule is from this one, means this one from this. Means the position of the methyl must be the same. So means the phenol, right, is should look like this, and the benzene diazonium chloride should look like this, with these methyl groups. And this one is the coupling reaction. Means actually this is the mechanism is electrophilic substitution. So because phenol is electron donating group, it will direct 2, 4, or 6. So let's say it's the direct 4 position. So means this benzene ring, right, in the phenol will form new bonding with the N. So this mechanism or this drawing no need to really know, just tell you how it makes. So this one form new bonding with this benzene diazonium ion, and this one of the bonds break, and these bonds break. After bond break, it will this nitrogen will get one lone pair. So actually it's like this, right? So means there is a new bond formations between the benzene ring and this nitrogen, and eventually this bond will break, pi bond break, and eventually it form N double bond, the azo link, and this nitrogen will get the lone pair, and after that it will form this azo die. So this is the azo link. So this is the molecule, di-molecule wise that form. If you cannot draw this structure with benzene ring, then you can draw this. This is from mark scheme. So it's actually similar. It just this one not really show the position of the methyl and the phenol. When you draw this benzene ring, you can show the positions, right? So it's CH3, C6, H4. Okay, 4 hydrogen here. 1, 2, 3, 4. Okay, N double bond here. And C6, H3, 1, 2, 3. And 1 CH3, OH. OH. Okay, and of course condition is this. For this, remember, for this coupling reaction, this reaction, when the phenol react with benzene diazonium chloride, it need to be alkaline condition. So it's sodium hydroxide aqueous. And of course temperature cannot be too high, or else the benzene diazonium ion will decompose. Let's say the condition is 5 degrees C. So the coupling reactions will happen and you form this molecule Y. Okay, I hope you understand, and thank you.